Hey Caleb, this is Bhagya. I'm recording for the assignment 5, which is family tree. So let's go with the basic structures first. I have created a class person with the properties ID, first name, last name, age, gender are the primary properties, and date of birth, date of death I created, but I'm not using it. So that is a basic structure of the person. I created node which has so I'm doing the graph with adjacency list, not the matrix. So it has the index, data, adjacent nodes, and weights as the properties. And then there is edge, which is from, to, and the weight for the direction and path, I mean the edge. So in the gender, I have created like a female, male, unknown, and created a class called gender extension, which gives me based on the user input in the form of string, and gives me the output as a gender enum. Another one is relation. So far I have just used like the marriage, children, siblings, divorced, adopted child, and parent as the relations in this application, and created a static extension class again, showing uh, defining the methods for getting the relation by weight, and the vice versa, like finding the relation by number and also finding the weight by relation. The underlying numbers is what I'm using as the weights. So there is another helper class called get the other directional relationship, which I'm using in this case for children parental relationship. So if the relation defined from one person to another is parent, then the other way is I'm using children, and vice versa. If the relation is defined as adopted child or children, then the other way to from is I'm using as a parent, just so it will be easy while reading the data in the user in UI. Next class is graph. So I think I forgot to put it here, but I used the reference from the C# data structures and algorithms that I have been following for C# language. So this has the properties directed, whether the graph is directed or weighted, and the property empty is empty, and the list of nodes, and the methods like add node, remove node, add edge, remove edge, find edge, update indices, and find edge if the indexes are given from M2. And the next one is family tree, the main higher level data structure for our assignment. So family tree, I have created a property called tree with the data structure graph, and which has the abstraction for person. So this has so the constructor initiates a tree, whether the directed or whether saying it is directed or weighted. I'm taking non-directed but weighted. So it has a function called add family member, which adds a person by creating a node to the tree and returns that node. Remove family member, which removes a person from the tree and also the relationships with that person. And there is add relationship, and this has some data assertions like the same persons cannot have any relation to themselves, and finding if these two persons have any existing relation, and if it is there, and if that existing relation is equal to the one the user is about to create, then um, throwing an exception saying this relationship already exists. If it is not equal, then there is already a relationship created between these two persons, as this is like adding the relationship. So two persons are related only in one relation way, not more than one relation way. So that is what I'm using. So this reverse relation is for parent and child relation. Just now I explained regarding the extension classes for relation. So if the from person 1 to person 2 relation is parent, this gives me the weight of the children relation. And if this person 1 to person 2 is a children relation, then this gives me the parental relation from the other one. So and the edge is added to the tree. So another function is defined called edit relationship. Again, a person cannot have a relationship um, to himself, finding the existing relation. If if there is no existing relation, then the user cannot edit a relationship. That's why this exception. And if the existing relation is equal to the input relation, then that relationship exists already. So there is no use of processing the action. So throwing an exception. And the another data assertion I'm using is if existing relationship is marriage between these two persons, then the only way to change the relationship is get divorced. And I'm not allowing to change the relation any other relationship, because like for my norms, like if one person and the other person are siblings, we cannot change that relationship. And if it is parent and child relationship, we cannot change that. Once a relationship is established, unless it's a marriage, I don't think we can remove that relationship. So that's what I'm using. So only if it is marriage, it is changed to divorced within between two persons. So otherwise, I'm throwing the exception saying only marriage between the persons can be changed to divorce. No other relationships can be modified. So remove relationship. Um, if there is any exist from person 1 to person 2, if there is any existing relationship, then it removes that edge. And if there is no existing relationship, it says there is no it throws an exception saying there is no relationship to remove. And these are helper functions called find node by person ID. This is used in the user interaction CLI, and this is a find relation, which is a helper function in finding if there is an existing relation between two persons. So let's run our program. Okay, so before running the program, let me give a small introduction here. So instantiating the family tree class, and then creating persons for Earnshaw family with the user input first name, last name, and gender. I'm not taking age into consideration here. I mean, like, it doesn't change anything here, so I'm just not using the age to add to the person. So here I have created a static ID property to increment the ID each time a person is created. So person 1, person 2, person 3, person 4, and I'm adding those persons to the family tree, adding family member. And then based on the document you have given, establishing the relationships between each two persons, like marriage, children, siblings. Next family is Linton family, adding family members and creating relationships. Next are the next generation families, created Francis and Harrington and Shaw, added the family members, added the relationships for Kathy Linton and Linton Heathcliff. So that is all. So at the end of the given list of families from the document, it prints the relationships just between two persons, and then we will go ahead with the user interaction. Okay, let's start our application. Sorry, one second. Okay, so here, person with ID 1 and full name Patrick Henshaw has a relationship marriage with Hannah, has a relationship children. These are children to Patrick, Catherine Hindley. Same way, and then Catherine, if you take Catherine, she has a parent Patrick, and she has a parent Hannah. Siblings, and she's married to Edgar Linton with person ID 8, and they both have a child, Kathy Linton. So in the same way, I have looped the persons and the relationships here like this. And I have created a small interactive class here, CLI. So it says if you want to modify the family tree, yes, how do you want to modify the tree, and it presents you with few actions present, whether you want to add a person, edit a person, delete a person, add a relation, edit a relation, delete a relation. So let's go ahead with adding the person first. So choose the ID of the existing persons here. So let's go with 2, and the relationship is siblings. So as you can see here, 14th person Bhagyavara is added, has a relationship siblings with Hannah, and also as you can see here, Hannah has a relationship with Bhagya, siblings. So just like that, you can let's try another thing. So it has updated the first name here. I'm just editing the details of the person. Let's add a relation. 14. Yes. Let's go with the same ID. Let's go something for now. So it throws an error saying a person cannot have a relationship to themselves. So that is all for the application for the assignment family tree, assignment 6. Thank you.